Okay, that was good.
Is it recording?
Yes. Okay, we're gonna do D4.
Yes, sir.
We have a string. We have a block of wood. And the block of wood is 0.892. And the string is 1.65. And then we have a rifle. That is shooting a bullet. The rifle is 3.96. That's a heavy rifle. And we have a bullet that is 0.00239. And when the rifle fires the bullet fires the rifle, and the rifle moves back with a delta V of 1.2 meters per second. So we want to know how fast is the block traveling after the impact. Well, after the impact, the bullet should go into the block of wood and should cause the block of wood to move that way.
So,
Right? Now, we're going to assume that this is a perfect shot, and it goes in, and it doesn't cause any rotation in the board. The board just slides up nicely.
so it's inelastic.
So, yeah, a bullet would go into the wood and would just stay there.
So M1 plus M2.
So that's going to be inelastic. Now, how fast is the block traveling after impact? We're looking at, again, we have inelastic, so, well, we can do it the simple way or the hard way. The P, of course, has to equal to P prime. And afterwards, what's going to happen is we're going to have the 0.892, and we're going to have the bullet stuck in that, so the 0.002391 are going to be traveling at some speed. Did the thing have any momentum beforehand? No, it's just sitting there waiting to get shot. So we want to say, well, what is the total momentum before? And again, there's an easy way or a hard way to do this. We know that when the bullet fires the gun fires the bullet, they have equal amount of momentum going this way and this way. Right? Because that's an explosion equation. So there was no momentum to begin with. I pulled the trigger. Now suddenly there's momentum going both forward and back. If these are equal, do I need to find how much momentum the bullet had?
Yes.
No, you can skip that step. So you could skip this step entirely, or you can use the explosion equation and say M1 V1 equals negative M2 V2, and we can solve for that. Or we can just say, hey, the momentum in the rifle is equal to the momentum in the bullet, which is equal to the momentum before they collide over here. So really all I have to do is say how much momentum did the rifle have right after the shot, and that's going to be the 3.96 times the 1.2. So if we did the solving down here and figured out what it is for the bullet, then I'd have to stick this bullet thing in there, but again, it's going to be equal, so we might as well just skip that step, because why? So we're going to have this times this divided by this mess, so this mess comes underneath. And yeah, that goes there. And then we'll solve for B. That's the first step. B then asked, how high upward does it swing? Well, because it has some speed, it has some kinetic energy, and it's going to swing upward until it turns all into potential energy. So, like I said, we're going to assume that it swings there and doesn't rotate, because then we'd have rotational energy to worry about, but we're trying to keep it easy. Whoops. So we're going to say that the kinetic energy we lost is equal to the potential energy that we gained. And so then we say, I know kinetic energy is equal to mv squared over 2. And I know potential energy is equal to mgh. If I want to know how high it went, all that velocity is going to turn into height. So the mg is going to come down. The m is going to cancel. So I'm going to have h is going to equal to v squared. V we just figured out was 5.31. And of course, we want to divide by. And that gives us a height of 1.44. But once it gets up to its highest point, it's not going to just stay there. It's going to start rock back and forth in simple harmonic motion. And so then we say to ourselves, if I'm trying to find its period of oscillation, T equals 2 pi square root of L over G. So did I need to know any of the other stuff to answer C? No, not at all. The only thing I need to know about that was the only thing I haven't used yet, which was that. So that's going to go there. 2 pi. And that's going to give me 2.58 seconds. And all of those answers match the answer sheet.
Math special.
Really?